Hey guys, welcome to Six Tips. In this video, today we're gonna show you two things. How fire contractors using UT or ultrasonic testing are non-compliant and doing more harm to you. And secondly, how a sonic inspection is vastly different in ultrasonic testing than what we're about to show you. Let's dive in. All right, guys, welcome. I have Chad here.
Hi, guys.
Six Tips, drinking some coffee.
Cheers.
So what we're gonna be diving into here, this is a pulse echo. It's been making its way around the fire industry for the past couple years now. There's been a lot of questions coming out about this, and we wanted to provide some education for you guys on what type of ultrasound this is. I have had Chad design for me, and this is Chad, by the way. You guys have probably seen him in a few videos.
It's been a while.
It's been a little bit. He's our operations manager, but I had him design a blind test for me using this. Do you want to dive into that?
Yeah, we're gonna show just the how the PE gauge, pulse echo gauge works. We have 3 different sets of pipes right here. They're all the same schedule and same diameter. So Sid has no idea what the internal condition is, and we're going to show the data that we receive from the pulse echo gauge, and then we're gonna compare it against a sonic inspection.
Yeah, so I'm not gonna touch any of these pipes because he knows exactly what's in there. I have no idea what's going on in there, and I want this to be, I wanna show you guys what this is capable of doing. I have a 2.5 inch pipe here. The nominal thickness is supposed to be a 120, is that correct, Chad?
Yes, nominal thickness 120. Manufacturers usually make them about 10% less than that.
So we have a 110, 109, 108. You saw that 0.08 kind of show up.
So what we're seeing here is pretty much an average of 107 to 110. And we're also looking at an A scan there, so if there was any degradation to that wall,
we would know
we
what's
would
going
see a
on,
difference, but
all
we're
right,
seeing
so
great energy.
pretty much, I mean, this is repetitive there, and so I want to have Chad, if you want to have you jump up and we'll grab the next piece of pipe. See this one. Let's see, we got 108, 108, 109, 111s, okay, cool. 109, all right, so
there we go. So pretty much the exact same. Right now we're seeing all good wall.
All right, cool, we'll go to the next one. Here,
110, 109, 110, 109, 108, 110. So again, we're getting pretty much the exact same
thing
data from all 3 different sets of pipes.
All right, so what you guys are seeing here is we are getting the same data that we, for all 3 pipes. And I mean, based on this data, I would say, hey, these pipes are good. There's no wall thinning. They're within the average wall thickness, the standard wall nominal thickness, even with manufacturer standards of variance. And so, I mean, I would say that all of these would pass. Now, what I want to show you guys is the next part of this, which is, the sonic guided wave technology. And so this is stuff that we've been using since 2004. We've been using a pulse echo since 2004, but we're gonna dive into, this right here, which is gonna show you guys how this stuff works. So we have this set up on a 2 inch. All right.
So our blue wave that we're seeing is our live wave that we're scanning.
Yeah, so that's, so what's happening here is, as Chad was saying, this is our live wave. What's unique though is what you saw me doing with the pulse echo was it was doing, each point I was putting on is one test location. What this is doing, what's so unique about guided wave and what we've developed is we're sending 10,000 test points around this piece of pipe. And so I can hit go and I've gathered, another 10,000. Another 10,000, and I'm able to measure this stuff. And so this is significantly faster. We're able to identify. And so what I actually found here was this was a dry signal, and that dry signal is going to be, regarded to a dry signal pipe. So Chad, if you'll move the pipe again. Next pipe we have here is, let's see.
Same diameter, same schedule. We're just doing a sonic inspection to see the internal condition.
All right, hit start. All right, so this is different. So based on our non-destructive testing and our knowledge of this, I'm gonna say that this is the bad pipe.
That would be a pretty good guess.
I'm going to say that's the bad pipe. I'm 100%.
We have very little energy coming back in our receiving transducer, which would indicate that their internal condition is bad.
It's bad. Okay, so let's move on to the next pipe. So about our technology is this stuff, it really works.
It's live, it's quick.
It's fast.
And non-invasive.
And we run this through background and analytics and stuff, but all right, let's move on to this next piece of 2.5 inch. Okay, so this is unique too. So what we're seeing here is a wet signal instead of a dry signal. So this was set up on a dry pipe and we're seeing these leak waves that are in there. And what that is doing is that showing that there's water in there. That stuff that the pulse echo didn't pick up. And so what we're even gonna do now to really prove and show you guys the difference of this stuff is, we're actually gonna dump this stuff out. But what I wanna do and kind of discuss before this is, we designed this test because Chad, tell me a little bit about pulse echo, just kind of what wave it uses and the importance of a pulse echo.
So the pulse echo is going to be a bulk wave that goes from the outside diameter to the inside diameter to read the thickness of the wall. So if there was pitting or corrosion in there and you had to have the exact pinpoint of the PE gauge transducer on that portion, as we saw in our demonstration, all of the numbers around the circumference of the pipe were all the same. So they indicated that there was nothing wrong with the pipe, but that's just going to tell you the wall. Now with the sonic inspection, we're going to be able to identify dry, water, or obstruction and corrosion. So it is a different device of UT that indicates the actual true internal condition. It's like a replacement for a visual inspection.
Yeah, and this is why we wanted to create this video for you guys, is so that you could have the shrewdness when you're being offered non-invasive, non-destructive testing by Fire Contractors. What they're using is non-compliant. So when we look at NFPA 25, Chapter 14, the purpose of NFPA 25, Chapter 14 is to identify the internal condition of piping.
Yeah.
And so with that, the pulse echo, as you guys just saw in here, it's only identifying the wall. It didn't pick up air, it didn't pick up water, it just gave us, is the integrity of the pipe, being upheld at least? It was there wall thinning, and none of that happened. Then we brought in the guided wave, and what's unique about what we do, again, as Chad said, is it's going around that pipe. It's telling us the internal condition, and this is why this is so important, is because Fire Contractors and other type of services that are using pulse echo need to have, it can be used as a supplement. The pulse echo is a fantastic technology. It works impeccably well. But it needs to, for NFPA 25, Chapter 14 compliance, need to be accompanied with a visual or camera inspection or a sonic inspection to identify the obstruction inside. So if you've had these services, you need to go back to your preferred contractor, whoever it was, and say, hey, you know what? Based on what we have just learned, it's putting our facility, our patients, our occupants, our assets at risk. We want you to go back and do these inspections because you sold us what was supposed to be an internal inspection. It's not internal, it's wall thickness. And it's a great service. It can be used a little bit for some asset management stuff. We've been using it since almost 20 years we've been using a pulse echo. It's a really good piece of technology.
As a supplement.
As a supplement. We used to never use pulse echo, unless we wanted to true up readings that we were really concerned about. And so we're leaving you with this. I hope that you guys found this educational. Do you have anything you want to add in, Chad?
I just wanted to say the reason for being able to identify air and water is because plenty of dry and pre-action system that I've assessed will have standing water in it. Yep. So you have steel, you have air, you have water. You're going to have corrosion and pitting and obstruction material. Yeah. Same thing with the wet system. When you have air in there with the water and the steel, you're going to have trapped air corrosion. Yeah. And that's part of the biggest pipe failures in most warehouses and big box stores and overhead wet systems. So just being able to identify the internal condition other than the wall condition of actually what's truly inside of that pipe is the benefit of the sonic inspection compared to the pulse echo.
Yeah. Just two very different types of ultrasonic testing technologies. Ultrasound is NFPA code, but you guys need to be knowledgeable about what type of ultrasound is actually going to provide you the security and peace of mind when you leave your facility. And so thank you guys for tuning in. Chad, thank you so much for designing this little test to show the difference between pulse echo and our sonic inspection. And thank you guys. Have a wonderful day. See ya.
Thank you.
Oh, my coffee.